5 Mind-blowing engineering inventions. The ancient Greeks developed cranes for lifting heavy loads in the late 6th century BC. Crane hooks are often made from wrought iron, which is tough, malleable, and ductile. Forging is a common method for making crane hooks because it provides better structural integrity than other metalworking processes. A lifting hook is a device for grabbing and lifting loads by means of a device such as a hoist or crane. A lifting hook is usually equipped with a safety latch to prevent the disengagement of the lifting wire, rope sling, chain, or rope. Hook is an engineering invention which used to carry out engineering work such as lifting heavy object. There are different types of machines like tractors, cranes, JCB, which uses hooks frequently to carry out engineering works. Hooks are also used in tall buildings for lifting objects. Hooks are made up of strong iron. Hooks are connected to shafts, then shafts are connected to hydraulic machine, which helps to make hooks move to different angles with the help of motors. Hooks are commonly used in the construction and building industry for tasks such as hanging drywall sheets, suspending lighting fixtures and ceiling fans from ceilings, securing pipes and electrical wiring to walls and floors, holding tools and equipment in place during work activities, and lifting heavy objects using cranes or hoists. Overall, hooks are an essential component of any construction project as they provide a reliable means of fastening and securing objects in place. Their versatility makes them suitable for a wide range of applications across the construction industry. The power of sound. Sonic tractor beams. A sonic tractor beam is a device that uses sound waves to manipulate objects in midair. The technology uses an array of loudspeakers to create acoustic holograms that can hold, rotate, and move objects. Sound waves create regions of high and low pressure. The precisely timed sound waves create acoustic holograms that trap objects. The trapped objects can then be manipulated by the sound waves. Moving delicate objects on a production line. Transporting tiny drug capsules and microsurgical instruments through living tissue. Holding and controlling astronauts in zero gravity. Researchers from Bristol and Sussex University built the world's first sonic tractor beam. Researchers in the UK and Spain developed a device that uses an array of miniature loudspeakers to create acoustic holograms. Researchers at the University of Sussex created a device called Sound Bender that can bend sound around an obstacle to levitate an object on the other side. Artificial photosynthesis. Artificial photosynthesis is a chemical process that mimics plants' natural photosynthesis. It uses sunlight or artificial light, water, and carbon dioxide to convert into oxygen and carbohydrates. Light is absorbed, and electrons move to an excited state. This generates oxidizing and reducing agents that start chemical reactions. These reactions produce fuels like ethanol or methane. Benefits. Artificial photosynthesis could reduce greenhouse gases, it could help produce clean energy, and it could help reduce carbon emissions. The chemical equipment in a leaf is complex, and it's not easy to use for artificial photosynthesis. The conversion efficiencies are still modest. New organic mediators are being developed to improve stability and performance. Breakthroughs in cells based on hematite photoelectrodes are encouraging. Bioprinting and regenerative medicine. Bioprinting is a 3D printing technique used in regenerative medicine to create tissues and organs. The goal is to repair or replace damaged tissues. How does bioprinting work? Bioprinting uses biomaterials, cells, and biomolecules to create 3D structures. The process combines computer-aided design with the ability to create extracellular matrix (ECM)-like environments for cells. Bioprinting can be used to create patient-specific implants and in vitro models for drug screening. What are the applications of bioprinting? Tissue engineering. Bioprinting can create functional tissues and organs. Drug screening. Bioprinted models can be used to screen drugs without using animals. Food production. Bioprinting can be used to create animal-free meat. Space-based solar power. Space-based solar panels, or solar power satellites, SPS, collect energy from the sun and beam it back to Earth. The energy can be used to power remote locations and supplement the Earth's power grid. How it works. Solar panels in space use mirrors to reflect sunlight onto smaller solar collectors. The solar collectors generate energy. The energy is converted to microwaves or lasers. The microwaves or lasers are beamed to Earth. Receivers on Earth receive the energy. Advantages. More energy. Space-based solar panels can collect more energy because there's less atmospheric absorption and reflection. 24/7 power. Space-based solar panels can provide continuous power, regardless of weather conditions on Earth. Scalable. Space-based solar panels can be scaled up to provide more power as needed. Challenges. The required structures need to be very large, both in space and on Earth. The system needs to have high transmission efficiency. Current status.